Okay, so the last thing we need to do for this section is go back and forth between polar and rectangular equations now that we've done coordinates. So we're going to use those same conversions that we talked about before. X is r cosine theta, y is r sine theta. We're also going to use that r squared is equal to x squared plus y squared, or possibly r is equal to square root of x squared plus y squared. Okay, so we're going to use those conversions to go back and forth. So going from rectangular to polar, let's say we have something like 2x plus 3y equals 4. If you're in rectangular equation, all you have to do is substitute these first two. So x becomes r cosine and y becomes r sine. So putting those in here, we're going to have 2 r cosine and 3 r sine equals 4. Okay, so the substitution part on this is easier. Now to get it in the right form, we really want to have r equals and then a bunch of theta stuff. So we want to try to get this with r by itself to be in proper polar form. This one right here, you can see we can't put these terms together. One's a cosine, one's a sine. So usually we would want to get r by itself by combining terms, but this one we can't. So a trick to remember here is to factor the r out. So if we factor that r out, now we've got r by itself. We can divide by all of this stuff right here. So we're going to divide by that 2 cosine theta plus 3 sine theta. And then we're going to do the same thing on the other side, 2 cosine theta, 3 sine theta. Okay, so that's gone there. So now we get the equation r is equal to 4 over 2 cosine theta plus 3 sine theta. Okay, so in the rectangular version, it's this, which we recognize as a line. This is what a polar version of a line looks like. Okay, so those are two versions of the same equation. All right, let's try another one. Okay, so let's try this one as polar going to rectangular. So let's say that we have r equals 3 cosine theta. Okay, now in order to go in the reverse, we either have to have r cosine theta, r sine theta, r, or r squared. So we see this cosine theta right here, and we can't really do anything with that, but if we had r cosine theta, we could. So let's try multiplying the entire equation through by r. So that's going to give us r squared equals 3r cosine theta, and now we've got some things that we can work with. So r cosine theta is x, r squared is x squared plus y squared. So now we can go ahead and make a substitution. We've got x squared plus y squared equals 3x. You want to make sure when you change, you have to either be in all r's and thetas or all x's and y's. You can't have a mix of them. So you can't make a substitution until you can swap everything out. All right, now looking at this, you should recognize this as being a circle. We just got to get it into the right form. So we're going to move that 3x over, and I'm going to leave a little space. And I want to get this into the right form of a circle, so that means this needs to be something squared. So if you remember back to algebra, to get this into the right form of something squared, we've got to take the middle number, divide by 2, and square it. So, oh, I didn't pick good numbers here. All right, divide by 2 and square it. That would be 3/2 squared would be 9/4. And then over here would also be 9/4. Okay, sorry, I didn't mean to pick fractions here, but we'll power through. All right, so this is going to be x minus 3/2 squared plus y squared equals 9/4. And this you should recognize as a circle. It's centered at 3/2, 0 with radius 3/2. All right, that one wasn't too much fun. Let's try a very similar one that doesn't come out with fractions. Let's say we have r equals 8 sine theta. Okay, let's see how this one compares. So same thing, I can't do anything with sine theta, I need r sine theta. So let's multiply through this by r and see if that helps. That's going to give us r squared equals 8r sine theta. R squared I know is the same as x squared plus y squared. And r sine theta I know is the same as y. So it's going to give me 8y. Okay, so again, it's a circle. Let's get everything on one side. So it's going to look like this. And then here I want to, again, I want to divide by 2 and square it. This one's going to be a little bit better. So divide by 2, we get 4. Squared is 16. So we're going to add 16 to both sides. And now this is in the form of something squared. So we've got x squared, and then the y group comes out to be y minus 4 squared. So now you should recognize this as a circle. We've got the x squared and the y squared. It's centered at 0, positive 4. Remember, it's opposite signs. And radius equals 4. Okay, so if you don't remember that from your algebra days, this is the form of a circle. So HK is the center. It's always opposite sign. HK is the center, and then the number here is r squared, so you would take the square root to get r. But mostly, I think to get through the homework, you just need to recognize what shape this is. So as long as you can identify it as a circle, I think you're okay for the homework. Okay, let's try one more. Let's say that we have 3 secant theta, secant theta equals r. 3 secant theta equals r. Well, none of our conversions deal with secant, right? So let's get this into sine and cosine and see if we can do this better. So we know that secant is the same as 1 over cosine. And we know that we can clear a fraction by multiplying by the denominator. So let's multiply on both sides by cosine theta. So it's going to cancel on the left, and we've got 3. And on the right, we've got r cosine theta. And now we say, aha, I know what that is. That's the same as x. So this equation is the same as 3 equals x. Okay, so as an equation, you should recognize that as a vertical line. So that means that our original equation in polar form was also a vertical line. Okay, so this one's vertical.